Alright, we are solving polynomials by factoring. So we're doing some more factoring like we have been doing. But we're taking it a step further. If you'll remember back in Unit 5, when we factored, sometimes we took an extra step. What did we do after we factored with those factors? You may remember? What did we do with the factors as a final step?
No. I think we need to refresh the cube square root.
No. In Unit 5, when we factored, we set them equal to 0. And that gave us our x-intercepts. And so we can still do that even with all of these polynomials. So that's what we're going to do. We are going to completely factor first. So even though we do one thing, we're going to look because there might also be another difference of squares or a sum or a difference of cubes that we have to factor again. Once we are completely factored, then we set them equal to 0. So number 1, I have 2x squared plus 6x equals 0. What do I always look for first? A GCF. Does this one have a GCF?
Yes.
What is it?
2x.
2x. Both of those numbers are divisible by 2, and they both have an x. So when I divide by 2x, what's left?
3.
This one still has an x left, and then a plus 3. Because we only took out 2x. This one originally was 2x squared. Now what's left in parentheses here, check to see if that is a difference of squares or anything.
No.
It's nothing. So then we take each factor and we set it equal to 0. So 2x equals 0. How do I solve this? No. Divide by 2. If I divide both sides by 2, what's 0 divided by 2? 0.
So x equals 0. Okay.
And then I have x plus 3 equals 0. How do I solve this one? Subtract 3. And what is 0 minus 3? Negative 3. So this, the 2x squared plus 6x, has x-intercepts at both 0 and at negative 3. Are there any questions? Number 2. Look to see if there's a GCF.
Yes.
What's the GCF?
2x to the second.
2x squared. Good. So 4 and 10 are both divisible by 2, and they both have at least x squared. So when I divide this by 2x squared, what's left? 2x. Good. Minus just 5. Just 5 because this one was x squared and I divided out that entire x squared. All right. Now this is not a difference of squares or a difference of cubes or anything else.
So what do you do if you have an exponent?
Well, we're going to get there. So this is 2x squared equals 0. What do I do first?
Divide by 2.
Divide by 2. How do you get rid of a squared? We do the square root. And what is the square root of 0? 0. Then we have 2x minus 5 equals 0. So we add 5. And 0 plus 5 is 5. So 2x equals 5. And then what?
I mean, you would have divided by 2, but
Mhm.
I mean,
So 5 divided by 2, you're going to get 2.5. So when you have a decimal it stops. It's like 0.5, 0.25. I'm okay with you leaving that as a decimal. But if it's a repeating decimal or a really long, I don't want you rounding. I would rather you just leave the fraction. I'd rather you leave the fraction all the time. So just leave it as 5/2. But if you insist on putting a decimal, this one it would be okay because it's 2.5.
are we doing the 2 lessons today or just one?
All right, number 3.
Oh,
Is there a GCF? No. How many terms do we have? 2 terms. Is it a difference of squares or a sum or a difference of cubes? It's a difference of squares. X squared is a perfect square and 16 is a perfect square. So we're going to take the square root of both sides. What is the square root of x squared? Square root of x squared. X. What is the square root of 16? 4. So my A is 4, or my A is x, and my B is 4. What is the formula for the difference of squares? A plus B, A minus B. So this factors into x plus 4, x minus 4. Are either of these a difference of squares? Yes or no?
what does that mean?
A difference of squares? Can either of these be factored again?
No.
This one you might be like, oh, 4 is a perfect square. Well, that's just regular x. So it's not. So now we are ready to set each factor equal to 0. So x plus 4 equals 0. How do I solve this one? Subtract 4, and I get x equals -4. And then I have x minus 4 equals 0. So I would add 4 to both sides. And so I get x equals 4.
Then we leave it like that.
Yep.
So I was supposed to leave it right.
All right, number 4. Question number 4. Is there a GCF?
Yes.
Which one is it?
5.
Yeah, there is a GCF, and it is 5. Both of those are divisible by 5.
What about that?
They don't have to have an x. Your GCF can be just a number. That's okay. So it's just 5. And so when I divide both of those by 5, I'm left with x squared minus 4. Now look at this. Do I have a difference of squares? Yes, this one right here is a difference of squares. So I'm using that same formula as I did over here. So a is the square root of x squared, which is b is the square root of 4, which is 2. Now your GCF has to come down. That's part of your answer. And then we do x plus 2, x minus 2. Are either of these difference of squares? Or cubes or whatever? No. So we're ready to set equal to 0. Normally, you would set your GCF equal to 0. But if your GCF is just a number, you don't really do that. I don't say 5 equals 0. That doesn't make sense. So if your GCF doesn't have an x, it's still technically one of your factors, but we don't set it equal to 0. So I need to do x plus 2 equals 0. I think she's the last one. And how would I solve for x?
Minus 2 both sides.
So we subtract 2 from both sides,
Yeah.
and we get x equals negative 2. Now we have x minus 2 equals 0. If I add 2, I get x equals positive 2. Very good. Those of you that have come in late, you'll just need to go back and get the questions that you missed. Number 5. Is there a GCF?
No.
There's nothing that all 4 of them have in common. But once we do the 2 groups, because this is 4 terms, this is a grouping problem, then we'll have some GCFs. So go ahead and split up your 2 groups. And then we'll do the GCF of each group. So this first group, they both have x squared. So when I take out or divide out the x squared, what am I left with? Plus 1. What's the GCF on this group?
Technically be 4.
Negative 4.
Or negative 4.
Because if your first term is negative, your GCF has to be negative. And so when I divide out the negative 4, what am I left with? X plus 1. And then my factors, I take the outsides, x squared minus 4, and the inside, x plus 1. Can either of those two be factored down again?
No.
It's a difference of squares.
Oh.
X squared is a perfect square, and 4 is a perfect square. So if your a is the square root of x squared, what is a? And b is a square root of 4. which is 2. So that becomes x plus 2, x minus 2, and then we still have x plus 1. And now we have 3 factors, and those cannot be factored anymore.
So we set them all to 0?
Set them all to 0. X plus 2 equals 0. So x equals?
-2.
X minus 2 equals 0. So x equals?
2.
Positive 2. And x plus 1 equals 0. X equals -1. Good. Are there any questions? Let's go to number 6. Is there a GCF?
Yeah.
X. They all 3 have an X. So when I divide out an X from each of those, we get x squared plus 5x minus 24. All right, so on this one, this is a trinomial because it's 3 terms. So how do I factor these? Multiply to get -24 and add to get 5. What are those 2 numbers that can add to be 5 and multiply to be -24? 8 and -3. Good. So we have this x, and then we have x plus 8 and x minus 3. Can either of these be factored down? No. So we're going to set all of them equal to 0. So the first one is x equals 0. Is there anything else to do? No. Then we have x plus 8 equals 0. What about this one? We subtract 8 to get x equals -8. And then x minus 3 equals 0. We add 3 to get x equals 3. Any questions
So
on?
this is a combine of the lessons. This one that we're doing and
Yep.
the last one.
Yep. All right, number 7. Is there a GCF? What is it? 3. Which leaves me with x to the 4th minus 1. Can that one be factored?
No.
Are you sure? It can be. What is it?
Oh, it's a perfect.
Difference of squares. Yep, they're both. Anytime you have a variable with an even exponent, it's a perfect square. And then 1 is a perfect square. So this is a difference of squares. So a is the square root of x to the fourth, which is not x. It's what? X squared. Remember, we divide the exponent by 2 when we're taking a square root. We divide the exponent by 3 when we're taking the cube root. B is the square root of 1, which is 1. So this is 3 from my GCF. X squared plus 1. X squared minus 1. Can any of those be factored again?
Yes.
Which one?
The squared.
It's not both of them. Just this one. This one is a sum. It's a plus sign. And because that's x squared, this would be a sum of squares, but we don't have a sum of squares. We only have a difference of squares. So only this one can be broken down again. So A, huh? Because that's the formula for difference of squares. It's A plus B, A minus B. So A is the square root of x squared, which is
X.
B is the square root of 1, which is 1.
So that pretty much didn't really even do that.
Well, it made it x plus 1, x minus 1. There is a difference. And that's all. We can't factor any more of these. So we're going to set them equal to 0. My GCF was just 3. Since there's no x with it, it doesn't make sense to set that equal to 0. So we're going to do the next one. X squared plus 1 equals 0. What do I do first? Subtract 1. Then what? What's the square root of -1? No. Do what?
It's I.
It's I.
Good job.
And then we have x plus 1 equals 0. So we just subtract 1 to get -1. And then x minus 1 equals 0. We add 1 to get x equals 1. That was a tough one. Number 8. I want you to try as much of number 8 as you can. All right, so you should have done grouping. Taking out a 4x squared from the first. And a -9. X minus 8. So this is 4x squared minus 9 and x minus 8. This one is a difference of squares because everything in that is a perfect square.
So you picked the two GCFs and then put them in a set of
Mhm.
parentheses, and then
The other one, what was left in the parentheses, goes in this other one. Yep. So then we're doing a difference of squares. And the square root of 4x squared is 2x. And the square root of 9 is 3. So this is 2x plus 3, 2x minus 3, and also x minus 8. All of those are completed. We don't have any squares or cubes. So we set each one equal to 0. We subtract 3 first. And then we divide by 2. Just leave it as a fraction. It's easier that way. Then we have 2x minus 3 equals 0. We add 3 to both sides to get 2x equals 3. And then we divide by 2 to get x equals 3 over 2. And we also have x minus 8 equals 0. If we add 8, we get x equals 8, and we're done. Now the reason we haven't done any of the cubes is because those actually require the quadratic formula to solve. And these last two will have that, so we're not going to do 11 and 12. I want you to work on numbers 9, or just work on number 9 for right now. All right, number 9, we have this first group of 3x cubed minus 2x squared, and the second group of negative 108x plus 72. What is the GCF of the first group?
x squared.
Leaving you with
3x minus 2.
3x minus 2.
Yeah, then that's it. 36.
It's negative 36. Leaving you with 3x minus 2. Both of those are divisible by 36.
They're both?
Mm-hmm.
Oh, no.
Now, you knew that these parentheses were supposed to match. So if you went ahead and brought over this 3x minus 2, that should have given you a hint to find this negative 36. Because if you take negative 108 divided by 3, it's negative 36. And 72 divided by negative 36 is negative 2. Yeah. It's kind of like a cheat code, yeah. The problem is, if you had messed up over here, then you would have messed up over here. So this becomes x squared minus 36 and 3x minus 2. What is this? Difference of squares. So a is the square root of x squared, which is. B is the square root of 36, which is. So that one becomes x plus 6, x minus 6, and 3x minus 2. And now you can set each one equal to 0 and solve. So you get -6, +6, and 2/3. We're going to do number 10, and that will be the last one that we do. Is there a GCF? X. Which leaves us with x to the 4th minus 47x squared minus 98. This is a trinomial because there are 3 terms.
Multiply to get -98 and add to get -47.
Yep. Goodness. So you're looking for 2 numbers that multiply to be -98 and add to be -47.
What is it?
What are those 2 numbers?
They're -49 2.
-49 and 2.
Oh.
So I bring down this x. What goes in my parentheses?
Oh.
We got to start with x squared. Remember we do that when we've got the 4 and the 2 exponents?
Okay.
So this would be x squared minus 49 and x squared plus 2. Can any of those be factored down?
Yes. Yeah. They're both perfect. Dang, they perfect.
X squared minus 49 is a difference of squares.
Oh.
This one is nothing because it's, first of all, it's a plus, and 2 is not a perfect square.
Okay.
So just this middle thing right here. So A, what is your A? X, B, 7. So we've got x plus 7, x minus 7, x squared plus 2. And don't worry about doing that one. It's going to give you an imaginary number. You're not going to have any imaginary on your test. So we have x equals 0. What am I going to get when I set this one equal to 0? -7. And then for this one, I would get +7. Are there any questions?